Hello, hello. I guess we're started. Looking at the stream, this looks good. I think we are actually being streamed. And yeah, for the first time on this stream, you don't only see my bald head, but you see another, well, much less bald head here.
A
Yeah.
little bit of fur, a
This is a
little
first for
clipping.
us. Yeah, this is going to be a first for us, having two people on the stream at the same time. Should be pretty fun. Just let me have a look. Oh, this is hello, Graham. Good afternoon. Um, uh, okay, just to confirm this all is work, we can see Brian, we can see everything. Excellent. So, welcome all to the stream, or this very special stream, where it's not just going to be me, it's also going to be my colleague Brian, and we're going to talk about a very special topic today. Uh, but this topic might be important for most of you, but I would bet that Brian thinks it's very important for everybody.
It's a very important topic.
It's a very important topic.
I often
Just
ask this question.
just a quick chat to the stream, to the chat. Is the sound good? Can anybody confirm? Does the sound good? I I think it is because nobody's complaining. So hopefully it all is good. Okay, very good. Thank you very much, Graham. Okay, cool. So before we start, oh wow, okay. I have some Skype weirdness here. So Brian, you just kind of resize for a moment.
Very good.
We just pulled you right back. Okay, so let's kick it off with yourself, Brian.
Oh,
Introducing
sure.
who you are and what you do and why are
I'm
you so
just this
important.
guy.
Yeah.
Yeah, I'm just this guy. Um, I am the operational excellence lead for the Well Architected program at AWS. So in my role, I study what works for our customers and what works for people, and I learn a lot about what goes wrong and what goes right, and then I try and turn that into best practices. If you're familiar with Well Architected, the OE pillar is my content that I've developed between myself and other SMEs inside of AWS. But I'm all about operations.
Okay.
I think I'm one of those rare people who might be an operations enthusiast. So
You're
let's
not the
make
only one.
operations sexy again, okay?
You're not the only one. I think for the past 2 or 3 videos, I've been talking on operations only. So you've come to the right channel.
Very good.
Excellent. So, excellent. So this is Brian, and Brian is actually based out of the United States. So we're kind of doing a cross-ocean collaboration here. -5 hour difference between two of us, or plus, depending on what you look at. So this should be pretty fun to do. All right. So the topic of today that we're going to be talking about and looking into things is, oh, how did I name this thing? Is 85% CPU utilization good enough, right?
Yeah.
And we're going to be talking about metrics, telemetry, monitoring. I promise I'm going to be showing you again some console. This is not just going to be two guys talking. We're going to also be looking at some things. But I think the main point will be that we're going to start discussing about how you monitor or how do you collect metrics? What do you collect? Is that important, that what you collect? And well, how can you make sure you are collecting the right things, right? So Brian, is 85% CPU utilization good enough?
I don't know, Darko. Is 85% CPU utilization good enough?
Let's have a look. So let me actually switch to my desktop here.
And
Uh,
since I asked you that question, let me put all the context around it.
please do.
So ultimately, any value or threshold that you're looking at for a metric has to be determined based on understanding of how the application works.
Okay.
So for example, if you have 85% CPU utilization on your cache server, something is possibly horribly wrong. But if your transcoder is only running at 85%, you have a lot of headroom that you could take better advantage of. And if it's a domain controller, we probably need there to be a security involved because that value is just way out of whack.
Exactly. So I think the CPU metric, which a lot of people kind of just take for granted, and when I say a lot of people, I mean myself. So I build myself an autoscaling group. So when you create an autoscaling group on AWS, right? So let me try to do this from scratch right now. So I go to autoscaling groups and create an autoscaling group. Let's call it stream scaling type Bonanza, right? I'm gonna use a specific launch template I have already called Awesome Application. I'm just gonna use the latest version. That's all fine. Click Next. I'm gonna adhere to the launch template. Just do some basic things. So I want to show you here that not everything can be just so rosy when you do it from the start, and I understand why a lot of people make mistakes when they choose autoscaling or when they create autoscaling, because if you click next, I will ignore load balancing, which you shouldn't do. But if we do scaling policies, the first scaling policy that we show up is average CPU utilization, right? So this kind of brings a lot of people to, hey, that's a metric I should think of. And depending on how my CPUs are utilized, this is this is the metric or the information I have, which I will base my judgment. Should I auto scale or should I scale up or down? Right.
I got to ask something, Darko.
Yeah.
How did you arrive at the target value of 50?
I did not. This was the default. This is the default that's offered when you create an auto-scaling group on AWS, right? So the default is average CPU utilization and 50. Now, should you scale anything up if your average CPU utilization is 50%? I'm talking about EC2 instances here.
Well, really, that's the wrong question, right? Because you need to understand how is it your application actually consumes resources, and then make a determination off of that. So if you generally use 50% CPU utilization, but memory is an indicator of load for you, and when your memory is exhausted, you need to scale out, that's the thing we have to talk about. So really, CPU utilization is not the conversation. The conversation we need to have with the developers is, what is an indication of good? What does good look like? And how do we expect things to look?
And that's a good point, right? So who makes a decision? What do we scale based upon?
So it's definitely not me. That is to say, the developers are the people who understand the performance.
Okay.
By the way, if you don't know what it should be, it's great to just plug something in and then find out if things go wrong. I realize that's not really a comfortable thing to say, but if you've done load testing, then you probably have a good indication of what is what. If you don't really know what it's going to be like in the real world experience, choose anything. I'm going to use a term I love. It's not an excuse for doing a bad job. It's a way to get started. So what you have here might be the first wrong answer with the intent to iterate as quickly as possible, as a fast follow. So if you plug in 50 right now and we just see what happens, then we can adjust to it based on this real world experience.
Absolutely, right? So this is a great way to start, right? But then a lot of trial and error comes here. And this is really dependent on what kind of an application you run. So it's not, not everything is a web server, right? So not everything is a web application running on EC2 instances. This can really depend on what you do, right? Even for web servers, a metric of CPU utilization might not be the right one. No? So, but apparently this one is the easiest to collect, or this one is available from straight off the bat.
It's true. The most commonly referenced ones are the ones that are visible essentially external to your system. Exactly. Right? Because we can see the utilization of the CPU readily. But if you want to look at something that's a smaller metric like overall load or something that's internal to the system, we have to go to more effort to do that.
Exactly. So that's the point here. But my question here is, who? So you're an operations person, right? So you are the person who operates a production grade workload. Let's say, yeah. So who would then decide? Would you be as an architect or an operations person? Who would put this value here? All right. I guess. Would you just go and try with the CPU utilization or something else?
Well, ideally, we had an opportunity to do this in a parallel environment, and we could actually, if the developers aren't really aware of how to perform monitoring or how to figure out what good looks like, then operations staff or people more experienced with monitoring and observability can work with them, do some load testing and arrive at values. But depending on your organization, you might be in a DevOps scenario where you do absolutely everything, and then you are responsible for this. And you're also responsible for iterating on it. In other environments, there might be an operations team that takes that load away from you, so you don't have to maintain that service offering. Okay. So you might arrange with that team to set some values, and they might have guidance for you based on their knowledge of your workload. The best thing there, though, is if you have a good relationship with them, you can work together to iterate on it. So who's going to set this value? It's whoever's actually managing the system. Okay. But who needs to get the information is different, because I, as a developer, I need to know when this value is exceeded so I can understand what's going on in my workload and then either adjust these parameters or make changes to the workload. Like, well, let's go on and when we see a metric, let's figure out how we need to respond to it.
This is a very important point. Who needs to see that metric, right? Is it a system that just handles errors or bad metrics, or just an auto-scaling system that auto-scales things? Or are these metrics, or this basically telemetry, this information being emitted, should this be seen by the developers and the operations and the business folks as well?
I have an opinion there.
Okay. We
We
love opinions. Come on.
All right. So who needs to see metrics information? All right. So if they're going to use it, then they should have access to it. Or if they can take advantage of it, they should have access to it.
Okay.
So in this case, like, I always want the developers to have access to it regardless, because they need to understand the impact of the changes they make, because they may identify that they've had an unintended consequence, right? So if I push out a new change and CPU utilization goes up, what does that mean? And we don't actually know, right? It could be that it was so popular that people are diving on it and taking advantage of it right now, or it might be the case that we just put out something that's added a significant burden to the CPU utilization. So we need to figure that out at that point in time. But I just highlighted something that's kind of unfortunate. CPU is not enough to understand what actually happened.
Exactly.
We need to have more metrics that might indicate user behavior, like they're clicking on the function button.
Absolutely.
And that would allow us to make more sense of the CPU utilization impact.
Yeah. So if you just use a primitive metric or a primitive value such as CPU utilization, it might get you somewhere, but it might get you in a wrong way there. So understanding why you have CPU utilization so much as a single metric is not useful, right? So if we can track user usage, right, or if we can somehow emit that information again to some system about how are the user using our system, like a clickstream or something like that, that we can potentially understand that A, we have more users doing something much more heavy, or B, we have made a mistake in our code and our code actually is consuming more CPU right now. So that's kind of how I think. Yeah, go ahead.
I'm sorry, a little dead air there for a moment. If you have this also matters on the kind of workloads you're using. So for example, if your workload does a consistent process and you have consistent inputs to it, and you've added something into Optimizer to add feature set that isn't going to be user driven. Hey Skeleton, nice to see you. If that's the case, then maybe a CPU spike post an implementation when it's doing the work you expected really is a strong indicator. But that's based on our understanding of the workload again, which goes back to that relationship between the developer and the person who's actually assisting them with monitoring, even if they're the person doing it.
Correct. And I think one of the things we mentioned, I'm not sure if we put it in the title, but we talked about telemetry and metrics. Are those the same thing?
Oh, well, that's an interesting question. So metrics, if we just look at the term, refers to a measurement.
Okay.
If we talk about telemetry, well, that's data coming out of the system. That's things that we can measure. So metrics alone, that's not the exhaustive set of things we can take advantage of. As I sort of go up the stack or break this apart into separate problems, the application itself needs to emit telemetry, and that's it's typically in the form of either metrics that are directly emitted or logs that we can then later convert into metrics. We also need to capture measurements from the infrastructure or the platform. So if you're using an RDS service or you want to check your flows, that information we also want to gather. Going further up the stack, we really want, it's not really so much up the stack, up the use cases.
Okay.
We also want to be monitoring the things we're dependent upon. So if you're dependent upon external DNS provider, we want to understand what the impact is there. We also want to understand user behavior so that we can detect anomalies. So if we don't get user behavior information, that'll never be an option. And then finally, one of the really useful points of telemetry is actually doing traces through a distributed tracing system, like X-ray, for example, where we actually sample and track a transaction as it flows across the system. And in that sample, we can see hotspots or zones or changes in behavior to recognize if there is something we could focus on for improvement. So we got those options to start with. But what we do with them is what really matters. Yeah.
So Skeleton X asks, is it fair to say that telemetry generates metrics?
Well, telemetry can be used to create metrics, but it's not implicitly that. That log, depending on the content of the message, that can't necessarily be converted into a metric.
Exactly.
But if we're looking for how frequently it occurs, or we're even looking for just one instance of it as an indicator of an error, then we can use that as a metric and we can convert that into action. through scripting and things like that. Telemetry, does it generate metrics? Well, generally your distributed telemetry systems, distributed tracing systems will give you information about like the time on a target or the latency before a response, and that effectively is metrics.
Correct. So think of telemetry, Skeleton, like any information your system emits. So that can be logs, that can be actual information on CPU utilization, on memory usage, or user activity. Some of that telemetry cannot be turned into metrics, right? So directly like so. So telemetry is basically any information being emitted by your system. And,
Yep.
and this is always a good point when I talk to customers is I ask them about their telemetry. So do they emit enough information for them to make good decisions? Has a change to the system been good or bad, right? So it's not all about autoscaling. So you have to emit this information, be that in the form of telemetry, yeah, and
Yes.
and converting them to metrics or sufficient metrics to actually make a decision. Has my code changed? Has my change to a different EC2 instance type, or has my new version of a library I use, has it actually made it better or worse? And unfortunately, a lot of the times the answer is no. They don't have that telemetry. And I think this is why we want to discuss this. How do you know is a certain metric or a certain value you have? How do you know that gives you the right information on the status of your system, on the performance of your system as well? So.
It's internal health and whether or not it's actually achieving the outcomes we're looking for.
Correct.
Incidentally, can I touch on that for a moment?
Mm-hmm.
It's easy to start the conversation about monitoring around, I like the ISO standard for network monitoring, which is FCAPS. It's F is for faults, A is for accounting, C is for configuration, P is for performance, and S for security.
Okay.
Out of order, pardon me. It's a great place to start the conversation because generally what we're monitoring for is fault detection or performance. That's very typical. But that doesn't actually tell us if we're succeeding. That just tells us what the issues might be in the environment. So what we ultimately have to get to is outcomes. And that often ends up being a combination of metrics put together to let us know we've achieved what we're trying to do. Or it might be like in your log file, Skeleton, you might recognize that the sale was completed, right? We sold something on our retail site. That's an outcome that's a success.
Correct.
Right. So so ultimately, just monitoring for faults and performance is not good enough. We have to get to outcomes, and then ideally beyond that, we grow into anomalies by studying user behavior and understanding the behavior of our workload.
Correct. I think that's a very fair assumption, or a very fair statement, I would say. Now, let me actually just show you something. So. This is I'm using a quick case of a user autoscaling group here as an example, which is great, right? It's kind of a lot of the times people when people use EC2 instances on AWS, they use it through autoscaling and they try to autoscale this to an extent. And one way you can do it is definitely through your CPU utilization, but how can you apply these custom telemetry or custom metrics? How can you create those custom metrics on AWS through a service called CloudWatch? Yeah. So CloudWatch, of course, I've been mentioning it a few times, is our monitoring and metrics and observability service. That's the new term, observability service. And it can collect metrics, right? So it basically collects information that can be turned into metrics. So this is the telemetry that actually applies to metrics. And one of those things is like, CPU utilization, disk writes, network out, network in, all of those kind of things. Now, if I had an instance and I want to emit certain information, or if I want to emit metrics, specific metrics, how can I do that? Well, luckily, and this is a great feature of CloudWatch, is that CloudWatch has the ability to emit or basically ingest custom metrics. So anything you wish to do. And let me show you how simple that is. So if I go to EC2, I'm just going to log into one of my EC2 instances I have here that I have launched recently. I believe I can just check it out like so. Yeah, this is one of my Stream Awesome instances. Just connect using Session Manager. Again,
Nice.
operations tool. Session Manager. There we go.
Very nice.
There we go. Bash. you should have seen my stream last time. I used Session Manager to connect to my Raspberry Pi.
Oh, very good.
Yeah.
I love it because it's so auditable.
Exactly. So I can do one thing like this. So let me do this.
I'm going to answer GBR7's question
sure.
there. Trends are definitely the most simple form of patterns of behavior. So it's an excellent way to go. Trending generally has an event horizon for taking action that's much more extended out, but we can use other tools to turn that into something that's more direct action. We should talk about that another time, Darko.
Yeah,
That's a deep dive there.
We can. I think this is an open forum for a lot of different things. So look at this command. I hope it doesn't execute. Yeah. So I'm just running AWS CLI command here called put metric data. So what am I doing is basically putting a metric, a number, a simple number of 5 to a metric I called stream page view count in a specific namespace called stream awesome page. So if I put this, hopefully, that's it. So I have not right now emitted information, whatever that is. In this case, it's a number 5 to CloudWatch, and this number will be collected as a metric. Now, you probably wouldn't do it like this through CLI, through a command line interface. You would do this through your application, through an API, for example. All of our API SDKs out there support this. So you can have your web application actually emit information directly into CloudWatch, and based off of the information you get from your application. Now, that can be number of transactions processed per minute. That can be number of new customers or number of Instagram filters applied. Doesn't really matter. That number can go directly to CloudWatch, and based off of that number, if I go to CloudWatch again, here, I can go and look at my metrics. Let's just do zoomed in. Go to all metrics, and I have it already selected here, but let me go like that. So you can see that I have a custom namespace called stream awesome page. And metrics will know dimensions because, well, they don't have dimensions. And this is the metric name I have selected to add to my graph. Now, you can see one point here that says 5. And that's the metric I've submitted here. Now, I've done this a few hours ago, and you might be able to see something. No, it's not available here. But basically, any information I emit here will be available and visible within this metric. Now, once this metric is available, I can just go here and create an alarm, I can just select this metric, right? Select this one, select it, give it what kind of a statistic I want. Now, this is also very important, right? When we talk about the statistics of a metric, which one should you choose?
That's a great question. But it depends what the metric is, right? So that sum one is excellent for if there's a threshold. So let's consider an error rate.
Yeah.
Perhaps we don't care if there's 1 or 2 errors. Actually, let's take a different one that security is more interested in. If we have 1 failed login every 10 minutes, that's not so bad. If we have 30,000 failed logins in 10 minutes, that's really bad. So sum's a great option there. If we're looking at something like average utilization, where we expect consistent behavior, that makes good sense. P90 though gives us a view on the outliers.
Yes.
So, and minimum maximum are excellent for the aberrant cases, the things that are really weird and out there. So it depends on what you're doing, right? I hate the it depends answer. We're going to start using instead the use case. We have to talk about the use case we have, and then we'll choose which metric which statistic makes the most sense.
Absolutely right. So, I mean, in this case, and Graham says here he gets confused by these, and I get it. And these can be, you have to make sure you pick the right one. And Brian really explained it nicely how you can use this in specific scenarios. Like the number here I'm using is page views, or I mean, it's a random telemetry metric I'm emitting, doesn't matter. But if you use like page reviews, you can maybe use just an average page view per minute to understand how much page views you have per minute for a specific page, and then, or for a specific group of pages, then you might do an average number to get maybe some scaling requirements.
But if your base views on, if your minimum views on your base page is 0 for an extended period of time, there's a good chance something else is wrong.
Absolutely, absolutely, yeah.
Right. So that's a great way to use that to trigger an investigation.
Exactly. So in this case, this is just using for an auto scaling. So I'm just using like an average over a 5-minute period, the number of page views or dummy metrics, dark limits. And based off of that, I can, say, hey, if the average view is more than 10, do something, create an alarm. Basically, this will generate an alarm to, well, in this case, do nothing. But if I attach it to, let me call it stream page alarm. If I do it like this, it will basically create an alarm if the average is 5 right now, right? So you can see here the number on this is 5, but if the average would be above 10, the alarm would be triggered, and then you can do anything you want. You can auto scale. So on auto scaling groups, instead of selecting a 85% CPU utilization, you can select an alarm that you created like this from, well, a simple command line or an API call, right? So
the best part is you're doing it on something that you really understand, right? So as a developer, you know this is the right metric to be using for scaling out based on your understanding of the application.
Exactly, and the fact that you can do this through the CLI or through the API, through the use of our SDKs, gives your developers the ability to actually do this, right? So to make integration, basically emit the information they want to CloudWatch, and then somebody at the other side from operations or from architecture or from DevOps, whatever you would like to call it, can actually make that auto scaling happen at a certain point. Right? So this really makes it possible that we get the proper information being emitted by the developers. Right? It gives you the ability to do that.
Okay. Jeeber 7 has a couple of questions. Let's see here. Oh, by the way, Jeeber, if you saw, there was anomaly detection was one of the options when Darko was looking at how to set up the alarm.
Yes.
We'll come back to that another day, though. You mentioned the other day that email triggered alarms are not worth it. So what is the best way to take an alert which might need investigating? Well, the classic example is that it's getting emailed a notification that your email system is down doesn't work well. So generally, I try and get people to consider using at least multiple methods. So you can use SNS and send it out to a pager, an email, or you could possibly link it to a call system. But the important thing is to try and get guaranteed delivery in some format. There's got to be someone who knows, right? And this goes into incident event management. So let's write that one down for another day too. Okay, the escalation and notification would be a really good conversation to have.
Absolutely.
But the best way, try and get multiple targets, and when all else fails, call somebody.
But here's the thing. I remember me talking about this. What Graham is saying here. I was saying that email triggered alarms or alarms that trigger emails are useless unless you have an action plan behind them, right? So that's the point. So emails are noise, absolutely. Emails are just noise, and the only times email notifications are not noise is if you only get an email when something is absolutely wrong and you can do something about it. So let's say I have my page view metric, right? And I create an alarm that if my page views go over 1,000 or over 9,000, I will receive an alarm, and my course of action as soon as I receive that alarm is to go and, I don't know, crank a new server up or do something, right? This has to be some sort of an how do you call it, a playbook or a runbook or I believe you, Brian, you said something once, a proper term for that. Is it
so because we have an expected outcome, that would be a runbook. A runbook is a procedure that yields an outcome. So in this case, we're scaling out to support the additional load. By the way, I want to highlight something else you mentioned there. Without an action plan, it's not valuable. You should not alert on anything unless there will be action.
Exactly.
Just don't do it, because you start training people to ignore the noise.
Yes.
So unless there's an action behind the alert with a specific process or procedure that will be executed, procedure if you know how to fix it, process if you're going to be doing a diagnosis, then don't alert. Yep. Have a process per alert. Well done, sir.
Have a process per alert. Absolutely, I think and I come from a company where we used to literally, I would get SMS messages on my phone every time a CPU utilization would hit 70%. It was just not an average of 70% every 5 minutes. It was just every time a 70% reach is triggered, and I would literally just completely zone out my phone if it starts triggering because I don't care. It must be noise, and that's the problem. So you have to have a process per alert. So yeah, you thousands of emails just ignore it. Absolutely.
Hey, you start writing rules that just discard them for you, and there might be value in there, but you'll never find it. So it's definitely well, the best practice from Ops 6 and 7 in the OE pillar is to have a process per alert, including an escalation path. So if you're not able to resolve it, how are you going to take action beyond that?
See, that's a question I liked asking customers when I would do Well Architected reviews with them. Do you know your escalation path? And a lot of them, I'll just call my manager. Is that the correct escalation path? Or the manager will just say, let's call somebody else, right? So
might not be optimal, but you know what? If they're doing it consistently and it's an expected behavior, that's fine.
That's fine, yeah.
You know, a process doesn't have to be written down. If you're doing it consistently, that's your process.
Exactly. Yeah, that's fair point. Yeah.
Although realistically, anytime you're adding in a step where someone has to make a call, that's not so good. Mm-hmm. It would be better to actually know that if I can't fix this in 20 minutes, I call Darko. If Darko can't fix it in 15 minutes, then he calls the developer. That might be the best way to do things.
And also back to like metrics and telemetry. The more metrics you receive, then the more metrics. So metrics and telemetry are useless unless you process it properly, right? So unless you understand what it is and how you react to it. And the more of that you have, and the more understanding you have to your metrics and the information you receive, the more you can fine tune your processes, right? So you understand what is happening in your application. And here's the thing. Especially now, I've worked in a very traditional system, monoliths, single servers, bare metal and all that stuff. And it was relatively easy. You have one big box and you kind of handle it. But in a modern distributed system, so we talk the cloud, we talk serverless, we talk thousands of microservices. One of the key important things is, and I think we mentioned this, is that you have every part of your application, of your workload, or however you would like to call it, emit information, right? So, and I remember this talking to a customer of mine way back, which they had a complicated pipeline to do some data processing, doesn't really matter. And it consisted of multiple different workloads, microservices, macro services, whatnot, right? And I asked them, how do they know their system failed? They told them their outcomes are not being fulfilled. Fine, that is fair.
How long does that take to find out?
Exactly. And how do you know which element failed in the entire pipeline? They don't know because they don't emit health information from each of those elements. So, and again, the flip side of that is you have amazingly large microservice architectures with serverless, which cost, they can handle 100,000 people, in their service. They can cost, $200 a year, whatnot. But then if you emit too much data, your monitoring will be 3 times the cost of your architecture, of your infrastructure, right? So you have to make that balance to understand what you need to emit.
On that note, here's another one to write down for another time. I'm a big fan of flipping a feature configuration to turn on advanced telemetry.
Okay.
So when you need it and something's wrong, dynamically change the configuration of your system to enable additional logs to be dropped.
Yes.
Or additional metrics to be emitted. And then when you're done with that analysis, turn it back off. Because if those messages are just going to be ignored, then you're paying for the opportunity to ignore those messages. Yeah. So use them when you need them, turn them off when you don't.
So it's basically,
that's a great thing to talk about too.
Yeah, it's basically a way of doing, you would have an alarm or a trigger that would enable advanced metric collection, right?
Sure.
And then once that floodgate is opened, you get a big old flood of information that then you can later process and do something more with
it. Skeleton and Gerber. So it could be as easy as changing the log level from error to info. If you're familiar with feature toggles or something like app config, you can actually have the system dynamically checking in, and when you see the event, change the configuration in app config, so when they check in, they'll grab that and they'll change their logging level. With systems like instances, yes, you could actually go out to them and do that, or push a config in some other manner to actually turn it on. Absolutely, that's a valid way to do it. And it works with Lambda as well, because you can change the logging level in your Lambda. You can have things embedded in your function that are not used until it recognizes a config that says it should be doing so.
Correct, absolutely. So it's a feature toggle, I guess, in an essence.
Yeah, it's a feature toggle.
Yeah, it can be application-based feature toggle, so it can be as part of your application code, but it can also be a part of your infrastructure, such as triggering CloudWatch detailed metrics at a certain point and disabling when you don't need. So you can get a lot of information here.
That's a good point. It's not just push; it's also pull.
Yeah, exactly. So Graham, app config is a service I want to cover, but I never get a chance to it. It's basically a service that allows you to change configurations of your applications. Basically, it's a feature toggle to an extent service from AWS.
Oh,
I know.
A lot of other use cases.
I know. But from the onset, it's a service as part of Systems Manager, as a lot of things, that helps you basically push specific configurations to your applications. So,
tell you what, Darko, in about 6 weeks, we should do something about app config and the use cases for it, maybe.
Yeah.
Because I'll have I'm working on something with that team.
Excellent. Let's do that. So I hope I will have Brian here again as we go along, and I can see that he invited himself again. So
there you go. I'll be back.
Excellent. Cool. Yeah. So we're getting to the 45-minute mark. So just kind of I want to just kind of step back through one of the what things we talked about, and we can emphasize on this as well a bit more. So we started off with, is 85% CPU utilization good enough for us? I mean, the metric, is that good enough for scaling? And that was just an example of, is anything like that generic good enough for you to make good decisions? Most likely not, right? In essence, it would work, right?
If your use case supports it.
Exactly. But there's better way to do it, right? I always say, I like this quote, you can dig with an axe, but you shouldn't, right? So you can use 85% CPU utilization as a metric to autoscale, but there's probably better tools for that, or better ways to approach it, right? So understanding what your application load is like, or what is the bottleneck. And I think also a bottleneck here is very important. What is a bottleneck of your application that needs to trigger a scaling event, right? So, and this is what your developers, the folks building your application, need to not just tell you, but also build in to their application to emit that information.
It's also worthwhile to make sure you understand what hardware you're running on, or what your instance type is if you're using an instance, because the percentage of CPU might vary because you're actually going for a memory-intensive system. So if you're on a system with few CPUs and lots of memory, that CPU is the wrong call.
Absolutely. I'll give you an example. Long time ago now, I think it's almost 10 years ago, I worked for a company, and we had we were a traditional company split into system admins and application developer folks. And the application developer folks, their application was, I believe, a Java-based application that had super heavy disk writes and reads, right? So, and that was the bottleneck. And we had a virtual system that we can, in essence, scale out as much as you could in those days. And one of the things we asked for them, let us know when you're hitting the bottleneck, and we will add a new virtual machine. And they told us, you know what, it's too complicated for us to do that. Can you just get us the fastest disks out there? So we ended up spending like 10,000 euros back then to purchase this super fast solid state disks at that time. And that was the solution, because the application team couldn't or did not have an easy way to do it, to emit this information for us so we can understand, or we can basically trigger the scaling and distribution at the right time. But I believe that in the current state of things, it's so easy to do that. You've seen me do it in a single line of code. To emit such information, everybody should do that. Absolutely.
Very good.
So yeah, Where was it? Yes.
You were summarizing.
I was summarizing. Yeah, I get sidetracked.
So let me do my side summary if I could. The most important thing is the relationship between the people who understand the application and the people that are supporting getting information out of it and turning it into something actionable. Because they're the people who are going to help you figure out, they're going to work together to make actionable events. And that's the heart of it. What is the metric? What should it be? That's a determination. The best part being, though, once we get past faults and performance and accounting type things, the starting point of monitoring, getting to the point of monitoring for an outcome is what's really important. And those outcomes as metrics are extremely actionable. So it should be your target always to get to the point of understanding whether or not outcomes are being achieved.
Absolutely. I think that's very important. And again, the good point here is you have developers who know what should we monitor, but then the part of the ops in that DevOps team, or whatever you would like to call it, they know what action needs to be taken if that certain threshold, or if that certain information or alarm or whatnot is triggered. So this is where the entire singularity comes into in DevOps teams. So you can have developers help you out with this, or if you are a developer, you can help out your operations folks by emitting this information and telling them this is the thing we need to be wary of when we do auto scaling, and then the scaling part will be handled by somebody else. And again, it's not all about auto scaling. It's also about understanding the health and the performance. And one of the things I got, one of my customers told me is that they monitor everything. They literally monitor from single requests to their applications to, I don't know, discrete spike. It doesn't matter. All the things.
I'm going to ask the obvious question. Do they use that information?
And they do. So they have this amazing use case. So literally they're able to get information how much each commit of code has improved their workload. So they understand, in milliseconds or whatever metric they have, to understand how faster is a request right now. Have they reached the limit or not? So they're basically able to transfer the cost or actually the cost of running a system in the term of a cost of a single request to how much development time has been invested in that. So that's a really great way to justify a 3-month development plan of something, right? So you can.
That is very cool.
But again, you need to know what to do with that information. It's not just a matter of, hey, I have all this information, and let's just hope we can do something about it.
Another thing that would also be a similar vein, if you can emit a metric about what the value was that was delivered by the transaction, and then compare the sum of those values against the cost to operate the workload.
There you go.
That's a great way to understand your cost optimization and your value optimization and how it's impacted by your code.
Yeah, there has been a lot of things you can do. And again, it's very important. The whole point of this, our entire discussion today was collect the correct information. Don't just rely on the defaults, because you can do better. With the information collected, make sure you make the right decisions. So make sure you understand that data. And I would also say that collect just enough data. Don't collect too much, otherwise it's gonna just go away. It's gonna be wasted money.
Cool. Can I do a shameless plug for the show we're going to start doing?
I just wanted to say that, so please do.
Okay. So Darko and I are going to start a new Twitch series called What Went Wrong This Week. In fact, that's my email address at gmail.com. And we're going to focus on all the mistakes we've made and how we could have prevented them from having an impact, or how we could have mitigated the impact. So we're going to start out with some ones of ours. If you have ones that you want to share, then we will take those and use them in follow-on shows and talk about the architectural changes that might have prevented or mitigated, and the operations activities that might have been able to address it. And hopefully we'll just use it. It's bound to be funny because we've all been there, but exactly. We'll use it as education and learning from it, because after all, accidents happen and things go wrong and everything breaks always. But it's what happens after that event that really matters. So
yeah, so
we'll talk about it.
that show is gonna. I'm not sure where we're gonna start exactly. It's here, right? It's gonna be done on Wednesdays. I'm not. It's gonna be on a special Twitch channel, so I'm gonna share that information as soon as I have it. But you will be notified about it through all the social medias, and I will be probably restreaming that stream through my Twitch and all that stuff. So. Yeah, it's gonna be fun. I'm really looking forward to it because that person there has a lot of experience when it comes to I wouldn't say you're doing things wrong, but a lot of things a lot of things
I
went
have had
wrong
many
around you.
opportunities for learning.
Yeah. So Brian, can Graham have your Twitter?
My Twitter. Oh, sure. It's Brian Carlson QED. Let me BRIAN CARLSON QED.
Let me just share it in the chat.
Thanks.
Paste and wabam.
There you go.
There
That's
you go.
me. Oh, that's OED, is it?
QED.
Oh, fonts. What can I say?
Yeah, so we plan to do that sometime soon, so I'm sure it's going to be fun. And I want to bring Brian as well back on this show to talk about more operational things and operational goodness as we go along. So yeah, let me just switch back to our big old faces so we can look at you in full. Thank you very much for everybody for joining. It was really great to talk to. First of all, to talk to you, Brian.
Thank you. It was a pleasure to be here.
It's been more than fun, I would say. And I hope everybody else enjoyed this talk. It was a bit less of you looking at my screen and looking at the terminal, more of a discussion. And I think even next to all the talks and all the technical part I do on here, sometimes having a more of a, let's say, more of a discussion like this, more of an abstract discussion is very important, especially from people with experience such as Brian. So
I do like the concrete, though. It's really nice when we can talk about something that went wrong, or, well, as an example, and then show this is how you fix that, or this is what I would have done earlier if I had thought of it.
Yeah, there you go. Cool. So I guess that's it. Thank you very much, Brian, once again for joining.
Thank you, Darko.
And I will be seeing you all next week. What is this? Oh, today is Thursday already. Wow, almost weekend. So I will be seeing you all next Thursday for next Tuesday. Sorry, for an upcoming stream. I have no idea what I'm going to talk about. So if you have any questions, any ideas, any topics you would like me to cover as well, do send them my way. So once again, amazing weekend. Brian, thank you very much.
My pleasure.
And thank you very much for everybody here being on the stream. I will be seeing you next week. Bye-bye.
Bye-bye.